This video is intended to show you some strategies and examples of how to use the three main trig ratios to solve for unknowns in a triangle. So katoa is just a mnemonic to remind you which sides you are comparing to get which ratio and how that ratio relates to the angles. Now we will be looking in this video at how that ratio relates to a trig table. Hopefully I can get to the table and show it to you. How to find values in a table, and also how to find values using a graphing calculator. So let's get started. Suppose I have to find the value, they ask you to find the value of a certain trig function. Pay attention to what the ratios are. If they're asking you for tangent, you want to be thinking about the tangent ratio. And you want to pay attention to which angle they name and look at its position in the triangle. So if we are looking at tangent of angle A, we are looking for the opposite over the adjacent. The side opposite angle A in this triangle is 15, and the side adjacent to angle A is 38. So the tangent of angle A would equal 15 over 38. Now we normally will convert that to a decimal, and we will round that decimal off because it goes on for a very long time. So I would just do 15 divided by 38 on my calculator the same old way. It's approximately, so make your equal sign an almost equal to, squiggly, 0.3947. I'll round to the 10,000th place. So I have accuracy to 4 decimal places. Let's do that again. Suppose I want to find the sine of angle Z. Take a moment and think about that. Sine is opposite over hypotenuse. Find angle Z. It's over here. The side opposite angle Z is 9. The hypotenuse in this case is 41. So the sine of angle Z would equal opposite over hypotenuse. And again, you can use your calculator to divide. And remember, you do the top number divided by the bottom number. So on the calculator, you do the top number first and then the bottom number. And also remember that when you convert it to a decimal, this is an approximation. If you're rounding off, so you have to use an equal sign that's squiggly, which is an almost equal to or an about or approximate symbol. So 0.2195 would be my decimal approximation for the ratio of those sides. Now, we need to know how to find a trig function of an angle. In other words, what I'm looking at here is if I have a triangle with a 12-degree angle, a right triangle with a 12-degree angle, and I want to find the cosine of that angle, in other words, I'm finding the ratio of the adjacent to the hypotenuse, what will that ratio be? Now I can solve that using a trig table. I can look at my trig table, I find the column with cosine, I find the angle 12 degrees, and I go across on 12 degrees to cosine, and there's my answer, 0.9781. 0.9781. I could also do that on the calculator. It's a little bit more difficult with these calculators. If you have one of this kind, you have to notice that the word trig is written in yellow right above the probability button. So you have to do the second function, and then you have to scroll through so that you can find the cosine button. You type that in, and then you would type in the 12, and then you would hit enter, and you get the same answer that I got with the trig table a whole lot faster. You can also do it with a cell phone calculator. Now, when you're using a cell phone calculator, you need to be able to turn it sideways on the calculator to get to the trig functions. When you're using your cell phone calculator, pay attention to this button here before you even begin. That changes you from radians to degrees. We'll explore that more later. It's kind of like the difference between being metric or feet and inches. But we want to be in degree mode, so it defaults to degree mode, so leave it alone so that it doesn't say anything up there. And in this case, you have to actually enter the angle before the trig function. So I want to do the 12 degrees first, so I will type 12 and then the cosine button to get my decimal. And it's more decimal points than the regular calculator. You'll notice that this one is rounded off, 601. This one is 6007, many more decimal places. So it is more accurate. Suppose I want to find tangent of 49. Take a moment and see if you can find that on your calculator device. And let's check what answer you got using a trig table. So with a trig table, to find tangent of 49 degrees, I would simply go down to 49 and over to tangent, and I would get 1.15, 49 degrees, 1.1504. So this is pretty old-fashioned, but it still works. So now let's start solving for things using our trigonometry. I want to find the measure of that unknown angle. I know there's a relationship between that angle and the ratio of the sides. So the first step is going to be to look at that angle and the position of the other sides. These sides are adjacent to the angle and the hypotenuse of the triangle. Take a moment and think, which trig function uses adjacent and hypotenuse? So indeed, you're going to be using cosine of my unknown angle is equal to adjacent over hypotenuse. I use this symbol for my angle. It's called theta. It's a Greek letter. It's frequently used for our variable when we're doing trig, and the angle when we're doing trig. So I want to find that measure. Well, first I have to figure out what 15 over 16 is as a decimal. So again, I'm going to whip out my handy-dandy cell phone calculator because I imagine that is what most of you guys are using. Clear it and set it so you can see it. I'm going to do 15 divided by 16, and I get this decimal, 0.9375. So that's the ratio as cosine. But I'm curious, what's the angle? So what angle, when I put it into cosine, will give me that ratio? So I'm not looking for cosine of this number. I'm looking for cosine of something else that will give me that number. I need to do the inverse. I need to do backwards of cosine. So I'm not going to use the cosine button. Sorry. I'm instead going to do the second cosine. So I've got my ratio, and I want to do the second button. That's up here. And then you'll see cosine has a little -1 above it. That means you're doing the inverse operation, inverse function, and I get an answer. That tells me that theta is about, we'll say 20.36 degrees. Okay, point there. So I could again have used my trig table, a little harder in this case, but I know that the decimal for the cosine is 0.937. So I look in my cosine table, or like in my trig table, I go down the cosine column till I get to about 0.937, and it's around here. Here's 0.9336, here's 0.939, so it's somewhere between 20 and 21 degrees, and indeed our calculator told us it was 20.36 degrees. So let's try another one. Take a moment and look at this. Look at the angle. We'll call that angle theta, our unknown. We want to decide which trig function to use. What is the relative position of those sides compared to that angle? Which trig function would you use? Well, this is the opposite side and this is the adjacent side. The trig function that uses opposite and adjacent is tangent. So tangent of theta is going to equal 23 over 15. Again, we need to convert on our calculator, and I will use a different calculator this time for those of you that don't have a fancy-dancy calculator. on your cell phone or don't have a fancy cell phone, I'm going to do 23 divided by 15. And there's my decimal, 1.53333333, repeating. So that's 1.53 repeating. Notice I could use a normal equal sign in this case because I put the repeating bar to represent that going on forever. I didn't actually round off. Now again, I want to go backwards. I want to do the inverse tangent in order to get back to what is the angle. The symbol for that again is doing the tangent with a little tiny -1 as its exponent-ish, it looks like an exponent, of the 1.53 repeating, and that should give me my calculator answer for theta, for the angle. So on this calculator, to do that, I need to get to my trig functions by doing the second and then that button. I go over till I find the tangent with the little -1 that's telling me I'm doing the inverse operation. I hit enter, but now I need to enter that number, and I don't want to round off this time. I want to just enter that number that was on the calculator a moment ago. Most calculators have a feature where you can enter the last answer you got. And on these calculators, they're down here. Look for someplace that says ANS on your calculator. It's yellow. That means I do the second function to get to it. So I'm going to do second ANS, and it's going to plug in the answer I just had. And then I hit enter, and I get that my angle is about 56.88 degrees. I'm just going to round that off to about 57 degrees. We'll round up. So that is about 57 degrees is about what that angle would be. Again, I want you to know how to use a trig table because they are actually easier. So in this case, let's go back to here. We knew that tangent was 1.53333333. I look for that in my trig table. I find the tangent column. I go down that tangent column till I get to 1.53-ish. Here's 1.539. And I read across 57 degrees. So I hope you're appreciating the trig tables enough that you might actually print one and have it handy. The nice feature of this is that you don't have to worry if your calculator is in degrees or radians. It'll work because my trig table that I have here only has angles in degrees. Some trig tables will have them with radians. Let's do one where you know the angle, but now you want to find the missing side. Again, you're going to want to look at the angle and look at its relative position to the sides. This angle is adjacent to that side and also next to the hypotenuse. What trig function takes adjacent and hypotenuse? Cosine. So in this case, cosine of 34 degrees will equal my adjacent over my hypotenuse, which in this case is x over 19. So I can use my old-fashioned calculator, the good old TI-34, and I can just find the cosine of 34. So I do second trig, scroll over till I get to cosine, 34. I get my decimal, and so it's going to be about 0.829. We're going to set that equal to x over 19. Now, since I rounded this off, I'm going to still use sort of a squiggly equal sign because that's telling me I took a step where I rounded something off. I need to solve for x. It's been divided by 19. I need to clear that fraction. What do you do to clear a fraction? You multiply both sides by the denominator to clear that fraction. So I am going to multiply this side by 19, and that will give me x. Now, I've still got that decimal on the calculator. I'm going to go ahead and, you can just leave it there and go ahead and hit times 19, and it'll automatically insert that last answer that you had, the full decimal, not rounded, although the calculator does round off just at farther out decimal points. And I'm going to go ahead and write the answer is 15.75. Now you might notice that I rounded off to only 2 decimal points instead of 3. Essentially, every time you do an operation, whether it's multiplying or dividing, you want to drop one of your decimal points of accuracy. That's why you always want to start with as many points of accuracy as you can. Let's do another one. Here's my angle. Here are the two sides. One's given and the one I want to find. Look at the relative position of those sides to this angle. Which trig function would I use? This angle is opposite that side and adjacent to that side. It's adjacent to that side, but it's the hypotenuse. Silly me. There's the opposite side and the hypotenuse. So I'm going to be using the opposite over the hypotenuse in this case, and that's sine. So sine of 58 degrees is going to equal x over 40. So my first step could be to multiply or to figure out what is sine of 58 by using the table in this case. So I look at my table, I go down to 58 degrees, I go over to sine, and that's about 0.8480. Oops, wrong problem. So I can write that, but actually let me do this differently with you guys for a moment. I could just leave it as sine 58. That is some number. It's a number in my table or on my calculator, but it's just really a number. If I were solving for x, I would have to clear this fraction. I'm going to multiply both sides of this equality by 40, and I would write 40 times sine of 58 degrees is equal to x. And notice I have a hard equal sign. It's not an approximation because I haven't rounded this off at all yet. I'm doing this to point out to you that when we multiply, we usually put that number out in front of the sine function. And to remind you that this is a rule or an application, it's a function applied to the angle. That function is defined by our table or the table that's inserted secretly inside your calculator. It's not multiplication here. These are not variables. That's the name of a function. When you go to enter this into a calculator, you have to be very careful about your order of operations. Because if you're using your cell phone calculator, as I imagine many of you are doing, you have to first find the sine of 58 before you multiply by 40, or else you're going to get things that are wrong. So if you're doing this problem on your calculator, first you have to find the sine of 58, and then you have to multiply by 40. When you find the sine of 58, you have to start by typing in the 58. Now my calculator is in the second mode. I've got my inverse functions there, so you have to touch that button to get back to the default. And again, make sure it does not say radians up there. We're not using radians in this class. I want it in the default of degrees. So I type in my 58 degrees, I hit my sine button, and so that means this is 40 times 0.8480 rounded off is about equal to x. This is how you would show your work on a test. And then I would just say times 40, leaving it on the calculator. And then I would get 33.9219 is about equal to x. Now you might say, hey, Ms. Long, you didn't drop off a decimal point of accuracy that time. Why not? Well, because I didn't actually round it off to 0.8480 on the calculator. I kept the full length of the decimal on the calculator before I multiplied by 40. And so if I were to drop off a decimal point of accuracy, I would simply be dropping off this 4 here. But in fact, I dropped off a whole lot more than that to round it off. And that is the length of that side. That leg would be about, roughly 34, really, if you round up. So we could even round up, say 34 is about x. Now, I want you to try this last one on your own. Let's start by just having you set it up without me saying anything. This angle is opposite that side and adjacent to that side. So that means that I've got tangent. So tangent of 25 degrees is equal to 35 over x. It's always a little bit harder when your variable is in the denominator. I recommend you do this in 2 steps. We want to clear the denominator of that fraction. We want to clear that fraction by multiplying by the denominator. I don't like the x on the bottom. I'm going to multiply both sides by x. That means that x times tangent of 25 is equal to 35. And then I want the x alone, so I'm going to divide both sides of tangent of 25. So I'm going to get that x is going to equal 35 divided by tangent 25 degrees. So I'm going to use my table, just because I want you to get used to the table, to figure out what is tangent of 25 degrees. So I look at my table. Tangent is the last column, so I'm going to have to scroll way down to get to 25. And it's this last column here. Tangent of 25 is 0.4663. And then this next step, I am definitely using a calculator. I do not expect you guys to do long division with decimals. I'm going to do 35 divided by 0.4663. Take a moment always to look at your calculator to make sure you typed it in correctly. This is a place where students make mistakes if they're going too quickly and they don't push the buttons right. And that's very frustrating. So that is about 75. We'll just round that nicely because 75 is a nice number. So x is about 75. I hope these examples have been helpful to you. And I hope now you feel comfortable using a trig table.